Hello everyone, my name is Robert Munteanu. Welcome to a practical guide on when to render in your web application. We are going to start by defining a number of criteria on how to evaluate, which will help us evaluate which approach to choose when rendering. To do that, we will also introduce a simplistic but real life-like case study where we could evaluate the various rendering approaches. We'll then take a deep dive into the various tools and techniques that we can use to render our application and see them live in a demo. We'll of course wrap up with a conclusion and some resources. Now, when considering where to render, I have settled on these four classes of criteria. First of all, because we are mostly developers, we of course like to think about the developer experience. Normally, we should not forget about the user experience because we are mostly building these applications for our users. There is, of course, an impact on cost and infrastructure based on how we choose to render based on our technical stack and systems that we need to use. And in the end, there are, of course, organizational constraints that we need to be careful about. So let's dive into those. Right, as developers, we may have a preference versus backend or frontend. And of course, we have various preferences even in the backend and frontend areas. So that does impact our choice on when to render, which technologies we are familiar with, which technologies we want to use. There is a difference whether we like to use cloud native systems or if we would like to have things running more on-prem. There are things which we cannot do with on-premise, and there are systems there are things we cannot customize or we cannot deploy if we go with the cloud-native solutions, right? And that mirrors the vendor-based or in-house development, whether we want to do something which is commercially available off the shelf, or we like to get our hands dirty and develop various solutions ourselves. In terms of user experience, which is sometimes hard to quantify, I like to reach out to the core web vitals, which are a set of indicators, a set of metrics that can be gathered from web pages, from web applications, websites. These have been designed to be proxies, representations of good user experience. So the expectation is that if you do good on these metrics, if you do well on these metrics, then your users will have a delightful experience. And they are designed to be precise and measurable. So let's try to decipher a bit these very technical and precise definitions, right? The first one is the largest contentful paint, or LCP. And that is the concept of the biggest chunk of important content that gets rendered on your screen, whether this is a hero image, a video, a chunk of text. That is what the large block that your users are mostly interested about. And I would like to give a call out to this time to first byte metric, which influences the LCP, which means the first byte that your application sends after it receives the request. Then there's this concept of CLS, the cumulative layout shift, which represents things moving around on page, which is always annoying, and they often come at a bad time. And then lastly, we have the interaction to next paint, which measures the responsiveness of your application. You click, what happens, right? And that is, of course, the interaction needs to come quickly. There are various ways to measure them, both in the lab, so a system interacting with your website and trying to figure out how it goes, how fast it is, and in the field by gathering data live from your users. It has impact on SEO, so search engines can and will rank sites with core web vitals better, but let's just remember that we optimize for them because that means we optimize for our users, right? They're not an end goal in themselves, but they are here because they presumably mean a good experience for our users. And as an example, for the largest contentful paint, you can see an example, a screenshot, various screenshots from the mobile view of Google Web Search. And what you can see is that from the first frame, you don't have the LCP, the largest contentful paint, that block of text. But from the second frame on, the LCP has happened. The most important block of text is there. And it is visible as soon as possible. So that is an example of a good experience. You see various images loading later, other content, but the largest contentful paint happens early on. And if you want to see the cumulative layout shift in practice, you also have this mobile view example where you have two blocks of text, and after the page load, you have a button that pops up in the middle, and that can interfere negatively in a multitude of ways. It breaks the reading flow, right? If you're just reading the grid block of text, you just lost your track where you were. And if you're trying to click select, you just click the button with I don't know what negative side effects. So these are the kinds of experiences that we will look out for when evaluating the tools and the techniques for rendering. As I've said earlier, our choices of development tools have a cost on the infrastructure that we need to maintain and or pay for. There is a difference between having a fully static website and pushing it to object storage, or in the classical way via FTP, just upload our website somewhere and we have a storage cost and then egress cost, which we will pay anyway. Or if we want to run virtual machines, whether on-premise or in cloud, these have definitely higher levels of cost. Or containers, we typically pay for the time that these are active, right? Not necessarily running, but just we have these reserved. Whereas content delivery networks, they have different pricing models. You typically get invoiced on bandwidth or on views or function as a service. If you're aiming for that kind of a developer experience, they have also different cost model based on invocations. So our choices of where to render have an impact on the operations team and also on the bottom line of our organization. So that needs to be taken into account as well. And finally, there is this catch-all bucket of organizational constraints, where we take a look not just at us and what we desire, but our larger context. What is the skill set that is prevalent in our team or organization, and what skill sets we desire to achieve? How do we have different front-end and back-end teams? How do they interact? Do they have shared sprints and shared goals, or are they separated between strong contracts and work in a decoupled way? That is going to affect how we do our work. Do we have personalization goals that are achieved better or just achieved through client-side rendering? What is the lead time we expect for changes? Is it fine to have a batch job that publishes all our content, or do we need that runs every couple of hours, every 24 hours? Do we need to push changes instantly? That will also affect our desire, the way we choose to render. So let's move on to the case study. Like I would say half of the internet, this is about cats. We have a website dedicated to Inky, which is a cat with a story to tell. And the website you will see circled, outlined in orange, which is the largest block, right? That is the target of the largest contentful paint. And that is, Inky is a sort of a special cat. It's a fictional website, obviously. And he likes to read. And from time to time, he likes to post reviews of the books that he reads. And the latest one is of Mice and Men. And then there is some general information about Inky of his particular story about reading. So now what is particular about this website is that we have a workflow for it. We have a more complicated publishing process because, you know, Inky is a cat. You can't trust him just to publish whatever he says. Sometimes he can be mean. Sometimes he can be has a bit of a dirty mouth. So let's have him write his reviews, store them in a different system, and then we have a site administrator that manually lists them, and he pushes them to the website, right? And that means that we have two different data sources and two personas interacting with our website. So that being said, there are a number of rendering approaches that we can take, and these are not necessarily points on a scale. Those are more of a spectrum. We can evaluate them in terms of different criteria. So the simplest one is static content. We don't have anything happening at rendering time than just serving the static content. Then we have a server-side generation, and that means we have something running, a programming language running on our backend, whether it's Java or Node or Golang or Ruby or Rust, whatever. Then we take these server-side logic and we enhance it client-side, and we can either do it in a RESTful approach, which is mostly these days having a JSON endpoint exposed via HTTP, or we can use GraphQL, which is a different technology with different constraints. We can use, let's say, HTML-based fragment rendering with HTMX, or we can completely delegate the rendering to the edge via a content delivery network or a different edge system. And the ones marked with light bulbs are the ones which we are going to do deeper dives into and we are going to see into the demos. Now, the static rendering approach is pretty simple. We take that review, we include it into our website by just writing the content. It's very low tech. You just need a text editor and the way of pushing this. Of course, as a development experience, it's not necessarily the most wonderful one. It's of course, you can use a static site generator, whether you want to use Hugo or Jekyll or whatever you think is interesting, but in the end, it's not something that requires a lot of development work. In terms of server-side rendering, you would typically have a piece of pure code that runs on the server. This is something that you would see in a lot of Java server-side frameworks, where you have a service that uses a data access object to retrieve a domain object, which in our case is the review. And then you would return that review in your response and tell it to render in a certain template. And that template can be, as an example, the second code snippet that you see here, which is HTML based, and then some placeholders with expression language which get replaced with the model. Now, as soon as we want to enhance it client side, we will start having placeholders in our web page. So the first code snippet from above is just an empty div with an ID. And as soon as when the page loads, that is going to be empty. And then we will use a piece of JavaScript code to hit a JSON endpoint, which will give us the content of the review. And then this is pretty standard JavaScript client-side code, which extracts the JSON response, creates the custom HTML, and creates the elements that will hold the data, and they will be rendered. Of course, you can use frameworks for this, but the end experience is the same, right? You have placeholders and you fill them in with client-side code. GraphQL, these are some snippets generated that will represent code you would write when using the Apollo framework in JavaScript. On the server side, you would have a concept of resolvers. So for the review, you would return an object that you would populate somehow. You pull it from a static file, from a database, from a NoSQL store. And the client side, you would have more of control. You would have a contract. Indeed, that's what separates GraphQL a bit from REST, is that you have a schema published, where you expose all the operations, whether they are queries for reading or mutations for writing, and you you would expose exactly what is available to the client side to access. And that is, in my view, the great difference between the so-called RESTful approaches and GraphQL, where GraphQL is more contract-based and allows a larger separation between your front-end and back-end teams, or the team that implements the client side and the team that implements the persistence. A different approach to client-side rendering is to use HTMX, which is a client-side framework, which interestingly enough does not require you to write JavaScript or expose things in JSON format. Instead, what HTMX does is to extend HTML, so it's an extension of HTML, to have additional attributes which can control client-side behavior. In our example, the first snippet tells that the contents of the div need to be replaced with whatever is served by /review.html via a get call. And the trigger is going to be the load event, but of course you can have different other triggers by clicking on buttons, scrollings, etc. And then the server-side code is whatever server-side you want to write, but it should return HTML in our case, right? And that is an example of a very simple template that needs to be rendered. And the interesting part is that you don't get to render a full HTML document, right? You get to render a snippet, because that is what gets rendered inside of that div, which makes it very easy to create partial, to render components. Now, the final approach is what is typically called edge rendering. So when a user wants to access your content, they don't directly access your website. That is denoted as origin in this diagram, but they access a CDN. And the CDN reaches out to your origin server, and if it finds special instructions in the page served by your origin, it can enrich that content before returning it to the user. And this would be called edge rendering, or maybe edge composition. The interesting part is that the rendering or the composition happen before the content is being served to the user. So the user does not wait for the page to load and then invokes the function that completes your page on the client side. Rather, the CDN does that for you. And this becomes interesting when you combine it with the caching possibilities of the CDN, because it gives you the opportunity to eliminate any waiting on the function or even on the origin, and thus return the answer to the response to the user very quickly. And the way this usually happens is that you have special instructions. In this case, the first code snippet shows an edge side include instruction, which gets interpreted by the CDN. And in this case, we have the div, which is going to be our review div, and we tell them, just go and call this function endpoint, which is usually invoked via HTTP, and include it. And then we can have any sort of function that generates the response. In this case, you see that we return a JavaScript object in the second snippet. Then after retrieving the title and the body, just creates an HTML body, which gets included as it is in the page. So if we were to take a look and say, how would we choose between these various rendering approaches? Let's take first cost and infrastructure, and how flexible, how powerful each of the approaches are in reaching our goals. Static rendering is obviously the one that has the least cost and requires us to have the least infrastructure available. At the same time, it is not as flexible as the other approaches. Edge rendering is obviously something that we need more infrastructure and or cost for, but also has a lot more flexibility. We have different systems running. They get composed at the edge, and we can have different life cycles. We can vary content, access policies, etc. in these two different systems. Now, server-side rendering is where, let's say, traditional development is at. Significant cost and infrastructure, and you can achieve most things with server-side rendering. Of course, if you add client-side REST enhancement or HTMX, you do not necessarily have additional cost because you can serve those with the same resource sources, but you have a lot more flexibility to achieve your goals by composing your pages on the client side. So personalization is much easier. Interactive web pages are much easier. And I've specifically placed GraphQL enhancement as requiring more cost and infrastructure, but also more flexibility, because I view it as a more heavyweight approach based on contracts and stricter separation between teams, which can give you more flexibility because the teams are more decoupled, but it also requires more maturity from the part of the organization. It also is usually not as easy to integrate into a caching infrastructure, so I would rank this as more cost heavy or infrastructure heavy. In terms of development experience, again, static rendering doesn't give you a lot of either on the front end or on the back end. Edge rendering is more focused on the back end, and server-side rendering, of course, is the most back-end experience that you can have. And then HTMX gives you more of a front-end experience because it allows you to do things dynamically on the client side, but still the experience is mostly on the server side, whereas REST and GraphQL give you a lot of experience on the front-end side. So if you're looking for that, then that is perhaps the best combo for you. In terms of the core web vitals, right, it's whatever performs processing at render time will impact the largest contentful paint because it comes in later. So static rendering and edge rendering have a head start. And also, naturally, but worth calling out, whenever you do rendering on the client side, you can have an impact on the cumulative layout shift. There are various techniques that you can use for that, but you also need to take this into account. Okay, so that was a lot of talking. Let's jump to the demo. In the first part of the demo, we will take a look at what the experience looks like when developing with traffic server as a CDN and OpenWhisk as a functions backend. The static contents are served by the Apache HTTPD server. So this is the web page with the review right in the middle. If I open the source, I will see that the text is inline, the review text is inline. If I open the network tab, I see that there is only a resource to the HTML document. And that is because OpenWhisk, which contains the review output, has already been invoked by traffic server. So taking a look at the terminal, if I am to run a curl code to the traffic server, I see the review inline. Whereas if I make a curl call to my origin, the HTTPD server, I see that in place of the review, we have the edge side includes instruction. So let's take a look at the OpenWhisk rendering. So I invoke here the HTTP endpoint for an OpenWhisk action, and I see just the HTML rendered. And the code behind this is actually quite simple. But it is a JavaScript function which returns a body. And that is it. Of course, the contents could have been pulled from anywhere else. Here you can see some examples of the OpenWhisk CLI. So we can list our actions, we can invoke them separately. And of course, this is the source code. The other experience of using server-side rendering is exemplified by Apache Sling. Now, Apache Sling is RESTful by nature. It is a Java web development network, but we will not be touching on Java at all. what I want to show you is that we have a couple of resources here. So this in-key resource is our entry point for the application. And the review is the review that we have stored separately, want to pull in separately. I want to draw your attention to the fact that there are some properties on this review, so you can associate it with a database or NoSQL store entry. So the review is worth pointing out that it's stored differently from the main resource. Now, if I want to open the page itself, I will open it in the browser. The experience is similar. If you will take a closer look, you will see that there is a flash, right? This is the cumulative layout shift that is inherent to client-side aggregation that needs to be mitigated. If we take a look at the network tab, we see that we have a JSON endpoint that returns the content that we want. And taking a look at the source, we see the kind of code that we saw in the slides, right? The empty placeholder div and the JavaScript client-side call. Now, if we are to tweak the URL a bit and asks link to render the HTML format, we see that the end user experience is mostly the same. If we take a look at the network, though, we see that our page is hitting an HTML endpoint and getting back HTML, so not JSON. And in the source code, we see that there is no JavaScript invocation. We only have the HTMX attributes that indicate how to run. And this concludes our demo. So, as you've seen, there are many options for web application rendering. Of course, this is a general advice. Pick your priorities and optimize for those. If you were to leave with some tools takeaways, so Traffic Server and OpenWhisk Apache projects, they pair nicely for edge rendering, where Traffic Server acts as the CDN and OpenWhisk as the functions endpoint. And Apache's Link and HTMX, they're a great pair for RESTful backend-oriented applications, which allow you to enhance gradually on the client side without necessarily having a lot of front-end investment. If you want to reach out to me, I am available on Mastodon, on the Fosstodon instance. There is a companion GitHub repository for this talk, and also I will leave you with some resources for the various projects that I have been talking about. And of course, the web core vitals, which are important concepts to measure the end user experience. With that, I thank you for your time.